Okay, so now that we know how to simplify radicals, multiplying radicals is going to be just as easy. Let's learn the rules. Rule number one is we're going to multiply the coefficients together first. Rule number two is we're going to multiply the radicands, which is the numbers inside of the radical sign using the product rule. And the product rule is basically when you have root A times root B, it's just going to give you root A times B. You can multiply the numbers, and we saw that when we were multiplying root 2 times root 3 in the previous example. And then we're going to simplify the resulting radical. Okay, let's maybe do one side of this. Actually, yeah, we can only do one side of it. All right, let's try question number one. We have root 8. The little dot means it's multiplied by negative 3 root 2. Really, all this means is you're multiplying the radicals together and you're multiplying the coefficients together. What is the coefficient in front of the root 8? Just a 1. So that doesn't really matter. In fact, I'm going to rewrite. If there was a number there, we would have to consider it, but now we don't have to really worry about it. Our only coefficient is negative 3 times, we have root 8, and then we have root 2. Can we simplify root 8? We can make it into root 4 times root 2. And then we have another root 2 at the end. So if you're wondering what I'm doing, I move the negative 3 over here. I split this root 8 up into 4 times 2. And then this root 2 just ended up all the way at the back over there. I'm rearranging it because I like my coefficients to be in the front. I just feel like because of algebra, they make a lot more sense. And then I'm simplifying as I go. We have a really good situation here because we have a perfect square and we have two radicals that match up. So my perfect square is root 4 and the two radicals that match up are root 2 and root 2. So let's keep going. Negative 3 stays where it is. Square root of 4 is a whole number 2. And root 2 times root 2 gives us 2. So what would our final answer be? Negative 12. Question. Times 16? You definitely could. I just avoided doing that because in the next couple of examples, it's not that easy. So I feel if you can, definitely if you saw that, you could have done it. Question number 3. We have 5 root 10 times negative 7 root 12. So again, what I'm going to do is I'm going to put my coefficients together. We have 5 times negative 7. And if you guys wanted, really, you could go ahead and multiply it right away. Like, you don't have to rewrite it. We know 5 times negative 7 will be multiplied together. So we could just rewrite it as a negative 35. Now let's simplify the radicals that we have. So root 10 is going to split into root 5 times root 2. And root 12, we could simplify to give us 6 and 2 and 4 and 3. What do you think is the better option? Yep. Yeah, so let's go ahead and do root 4 times root 3. This is one of those questions that isn't very satisfying because all we end up with is one perfect square of root 4. Do we have any other matching pair of radicals? No. Can we simplify root 5? No. Root 2? No. Root 3? No. The general rule is if you end up with a prime number, you can't simplify it any further. So unfortunately, all we're going to have to do is we're going to have negative 35 times a whole number 2, because the root 4 becomes a 2. And then we're going to have to just multiply all of those radicals back together. So 5 times 2 is 10. 10 times 3 is 30. Root 30 is our radical, which cannot be simplified any further. And then negative 35 times 2 is just going to be negative 70 root 30. And if you're looking at this question and thinking, really, root 30, that's a massive number. I can think of ways to split it up. You can try anything, 3 times 10, 15 times 2, whatever you try, you won't ever find a matching pair or a square root. So that's really as simplified as it can get. That make sense? Okay. Let's do 3 more examples, and then we'll stop there. what happened to my what? Are there any questions? Oh, that's right. You know what I did? Okay, guys, so I put question number 5. This is a reminder of the rule. If you have root 16 times root 16, you could either multiply them together, but that's inefficient. You could take the square roots of them and get 4 and 4, or you can remember the rule is if you have two identical radicals, it's going to end up giving you just a whole number 16. All right, question number 7. This time we have 4 root 8 times root 15 times root 2. The only coefficient is a 4 because everything else is 1s. We can simplify root 8 to give us root 4 times root 2. We can simplify 15 to give us root 5 times root 3. And we cannot simplify root 2 either, so that is as far as we can go. Okay, so in this example, I have a perfect square of root 4, and I have a matching pair of root 2s. So I'm going to have a whole number 4 times a whole number 2 times another whole number 2. And then can I do anything with the root 5 times root 3? No? Yep, so all we're going to do is we're going to multiply them together. And our final answer is just going to be 16 root 15. Did you guys get that? Okay. All right, I really like question number 9 because it is a little bit of an order of operations question. So remember BEDMAS, we got to multiply before we can subtract. In fact, we haven't learned how to subtract it because I'm doing this lesson out of order. So we'll just try our best and we might dip into a future lesson. So we have a coefficient of 10 and another coefficient of 3. 10 times 3 is 30. Then we have root 2. I can simplify root 10 to give me root 2 times root 5. Well, yeah, because of BEDMAS, we have to do the multiplication first, and then we'll do the subtraction after. That's okay. So I multiplied 10 and 3 to give me 30. Then I kept the root 2 there. I simplified root 10 into 2 and 5. I have a matching pair of radicals of 2s. So this is going to be 30 times 2 times root 5 minus 6 root 5. By the way, if you didn't want to show this much work, if you know that 30 times 2 is just 60, you can go ahead and simplify that right away. Okay, and then this next part is going to bring us to tomorrow's lesson, but I'll give you a sneak peek. If you have two radicals that are the same, like 5s, it's kind of like having the same variable. So this is sort of like saying 60x minus 6x. If you had 60x minus 6x, what would that give you? 54x. So this would just be 54 root 5. Radicals behave in a very similar way to variables. And then you'll learn a little bit more about those later. Okay, now that's as far as I'm going to go because the next page of this we're going to do on Monday after you've learned how to add and subtract radicals tomorrow. So I'm going to pause here, and like I said, it is going to be a little bit of like skipping back and forth, which I apologize about.